Hey, good afternoon everyone. My name is Chris. I am a systems engineer and I've been doing systems engineering for about 15 years now. Started with defense work and then moved over to the autonomous vehicle space. Right now I'm in the midst of looking forward to a transition from systems engineering to software engineering. So as part of my effort in doing that, I have been trying to teach myself various pieces of programming, from basic syntax to data structures and algorithms, and so that's what I'm going to start with today. So keep in mind, I am not a software engineer, I am a systems engineer. I am not have the best and greatest, most efficient solutions. I've used code in my job as a systems engineer to automate my work, to make me more efficient at it, and I've found that that's what I enjoy, so I'm hoping to branch out here. So I figure I'll start with a fairly simple Leetcode problem. This is one that I'm picking up today. I've done a bunch of similar ones before though, so let's get right into it. So the one that I'm looking at is 268, missing number. So for this we're given an array of numbers containing n distinct elements in the range 0 to n. And they want us to return only the number in the range that's missing from the array. So since arrays are 0 indexed, if I have an array that goes with 5 elements, then the elements that are going to be in there are going to be 0, 1, 2, 3, 4, potentially, with 1 missing is 5. In order for me to see all of those numbers, I would need an array of length n plus 1. And that's kind of how I think I'm going to approach this today. So some of the stuff that I've done in my daytime job is I've had to compare two sets of data. And so one of the things I look for when I'm comparing these sets of data based on the work that I do is, do I have something that's in one array and not in another, and vice versa. So I can find, if I have a set of test data, then does that test data contain all of the things that I was expecting it to have? Is there anything missing? And then I also want to check, does my test data contain something that I didn't expect to be in there based on my source data? So Python has a nifty little thing that they call list comprehension, which is what I'm going to use here. So we'll start getting into it right here. I'm going to type it straight into Leetcode. I also will probably go back and add this to my own GitHub repo that I have that I've been building as I go through and solve Leetcode problems. I think I've got about 25 or so that I've worked out. So the first thing that we're going to need to do is we need the length of the array. So we'll start with n is going to be equal to the length of nums. So that'll give us that, and then the next thing that I want to do is I want to create what the full list would be for something that goes 0 to n. So in this case, I'm going to create a new variable, we'll call it full list, and I'm going to set that to be a list, and I'm going to use the range function in Python. And in Python, you can use range, and if you do a value like 5, then it'll create an array that is of length 5 starting from 0. So range 5 would give you 0, 1, 2, 3, 4, which is not what we want here. We want to go all the way up to n, 0 to n. So I'm going to do range of n plus 1. So for example, the first input that they give, nums equals 3, 0, 1. So with that, the length is 3, and what we want is we want our full list to go 0 to 3. So we want a list that's going to be 4 digits. So the next thing I'm going to do, I don't like returning just the value straight off, though I probably could. I usually give something called a result first, and this is where I'm going to use the list comprehension. So I'm going to create a new list. I'm going to go x for x. In, and here I need to pick the correct list that I want to use. So if it's in the original list of nums, So x for x in nums if x not in the full list. And so the way this works is I love list comprehension because it's exactly what it sounds like. It's going to look for x, whatever the variable is, in the list of numbers. And it's going to return that number if it's not also in the full list. And now I need to double check this to see if I got that correct or if it's backwards, because I think it's backwards now. Yeah. Because if I do x for x, so if it's in nums but not in that, and it's the other way around. So I want, if it's in the full list, so we're going to go through the entire full list, and if it's not in the original array that we're given, then we know that's the missing value, and then we should just be able to return that. This is going to return an array, so what I actually want is the value that's given there, so I'm going to do, I know it's going to be the first one, so I can do result of 0, and this will give me just the value itself. Otherwise I would be returning a list, and that's not what they're looking for. And then if I scroll down here to the bottom, I think this will work. I don't have to worry about edge case scenarios because it does say here that I have n is going to equal the length of the array, and that n is always going to be greater than or equal to 1. So I don't have to worry about a zero-sized array. Otherwise, I put in a separate if statement to look there. And so just based on this, I think our time complexity is going to be O of n, and our space complexity is going to be O of n as well, because we're going to need to create a whole nother array. So that's what it reduces down to. So if I understand big O notation, you know, it'd be n plus 1 for time, but the constant goes away, and same thing, you'd have, you know, the length of one array, and then we're going to create another one that's going to be n plus 1 array, so we have to have 2 arrays in there, and this just narrows it down. So let's go ahead and run it here first. Cool. And so it looks like it passed all the test cases there. So I'm going to go ahead and hit submit and let it run through the rest of its test cases. And that's funny. So it beats 5% according to this. So not exactly the fastest algorithm that we could have used here. I'm going to go ahead and run it or submit it again and see if it gives me a different number, because I've heard that you can do that. Okay, it's still taking about the same time, but it does work. So the next thing that I'm going to do here is I'm going to copy this over, and I've got a link on my own site to be able to go to some big O resources, and this big O calculator I love because I can just paste this in here, and let's see how close I was with figuring out what our time and space complexity was. And I am way off here. So apparently list comprehension is actually an n squared operation, which makes sense. Well, that's why I'm only in the, beats 5%. Because we're going through and we have an n squared time complexity. But we are right, it was O of n for space complexity. So there's probably a better way to do this. But like I said, I am not a software engineer, so right now I'm just trying to get through, can I solve the problem, and let's work on optimization later. And this actually ties in a lot with how I've done things in systems engineering as well. You know, the enemy of good is perfect, right? So I'm not going to look for necessarily the perfect solution as the first thing that I do. I want to get a working solution first. Once I've got a working solution, then let's think about it a little bit more, and how can we narrow this down? How can we make it faster? How can we use less space? And that's where we'll get to. But hey, I've got a working one, and that's where I will stop for now.